And now we're going to get into finding the unit vector with the same direction as a given vector. So this is where we're using, we're saying, oh, we have u, the vector u, is equivalent to our vector v divided by the magnitude of v. We're basically finding it in a different spot. It's the same direction. We're basically looking at a different piece for it. So what we're going to do is we're going to look at that for our v, and then we need to find the magnitude of v by using that distance formula. So that distance formula, because we are not looking at two different ones, we're just finding the magnitude of the singular one. So how we write it is it's just going to be the square root of -2 squared plus 3 squared. We're not doing anything else. It's like a basic Pythagorean theorem. So the magnitude of vector v is going to come out to be, what is that? Square root of 13. So we're going to list this off as, now we can either put it as this, or we can separate it out. The other option is 1 over the absolute value of v times v. I don't mind either way. I'm just going to go ahead and do -2 comma 3 over the absolute value of v, which is root 13. Now what we need to do is we're going to split them off, and we're going to divide each of them over root 13. This is a scalar multiplier. People in like doing this first piece or the second one that I circled better because it looks more like scalar multiplication. The way I wrote it is less like it. So you can also write it as 1 over root 13 times -2 comma 3, which might be easier for you to view because now you can multiply it by that 1 over root 13 scalar and get -2 over root 13 comma 3 over root 13. And then the last step is to rationalize it, and that gives you -2 root 13 over 13 comma 3 root 13 over 13. Lots of 13s in this one. Okay, and that right there is your final answer, and that is u. It has the same direction as vector v. You can obviously check it by plugging it back into the magnitude, but obviously no need to do it in this case. I'm actually going to give you guys one more example of this. I want to see if you can possibly do it on your own. So I'm going to move this out and away. Let's see. There we go. Okay, so let's do a second example just so you guys have some practice before you go into homework. We want to find a unit vector u. We want to find that if w is equivalent to the vector 6 comma -2. So following the path, the easier one is saying 1 over the magnitude of w times w is going to give us that u vector. So you're going to go ahead, do the Pythagorean theorem to find that magnitude of w, and then go ahead and then scalar multiply it with the w piece. Go ahead, pause it, try to do what you can, and then play it when you're ready, and I'll come back and show you how to do it or walk you through it if you are lost. If you are not lost, obviously just check your answer and you can move on. Okay, so hopefully that was enough time. Make sure to pause it if you didn't and you're just sitting there waiting for me. I want you guys to try it on your own. If you are completely and utterly lost, that is fine. I will walk you through it, and the rest of you, if you did it, check your answers. So first off, we need to find the magnitude of w, which is the distance formula, or the Pythagorean theorem, 6 squared plus -2 squared. We're going to take the square root of that. And that gives us 36 and, is that 4? So the square root of 40, oops, there's my pen. Square root of 40 And, you know, if we fix that, W is 2 root 10. Because you can pull out a perfect square. 4 in there, square root that. Okay, so now we've got 1 over 2 root 10 times the vector 6, negative 2. If you go ahead and distribute that through, that gives, in that first piece, 3 over root 10, comma, negative 1 over root 10. The 2's cancel in that one, and the 6 and 2 reduce. I'm going to go this way with it. Now we just have to rationalize. That gives us 3 root 10 over 10, comma, negative root 10 over 10. And there's your answer. So make sure if you did something wrong, you picked up on that error and you're able to continue on.